Hello all, this is Nandhini, Assistant Professor, Department of Computer Science at Dr. SNS Rajalakshmi College of Arts and Science. So in this video, we are going to discuss about natural feature tracking by detection. So let's discuss the natural feature tracking by detection in AR, so which is called as a NFT. It is a technique that allows digital content to be overlaid onto real world objects or environments, so without the need for special markers. So instead, the systems relies on recognizing and tracking natural features within the environment, so such as edges, corners, textures or patterns, so they are unique and distinguishable. So this is the small introduction about natural feature tracking by detection in AR. So this is the image for NFT. So how natural feature tracking by detection work? So first we have to capture the image. So the AR device such as smartphone, tablet or AR glasses, so they continuously capture the images or videos of the real world environment using its cameras. And the second step, feature detection. So the system analyzes the captured image then to detect natural features within the scene. So these features can include corners, edges, points of interest and textured areas, so that stand out from the surrounding environment. And the third step, feature matching. So once the features are detected, they are matched against a pre-existing database of features. So this database might be created from a reference image or model of the object or scene to be tracked. The system looks for correspondence between the detected features in the live camera feed and the stored features. The more matching points it finds, the more confident so it can be about the object's identity and its location within the scene. And next step is pose estimation. So after matching the natural features, the system estimates the position and orientation. So the orientation is nothing but pose of the object or environment relative to the cameras. So the pose estimation, which is involves to calculating the object's 3D position and rotation. So it is allowing the AR system to understand where and how to place the digital content in relation to the real world features. And next step is tracking. So as the user moves the device or as the object itself moves, the system continuously tracks the natural feature and which is updating the pose estimation in real time. So this ensures that the digital content remains accurately, then it aligned with the real world objects and it is maintaining the illusion of seamless integrations. And the next step is rendering. So once the pose is estimated, the AR system renders the digital content such as 3D models, animations or information overlays onto the scene in the correct position and orientation. So the content appears to be to the natural features, so it moves and scales correctly as the user or object moves. And the last one is real-time interactions. So the user can interact with the augmented content by moving around, then pointing the device at different parts of the scene or touching the screen to interact with the virtual elements. So the system continuously updates the rendering based on the real-time position and orientation of the natural features. So these are the steps the natural features tracking by detection works in AR. And the next one is example. So first we have to imagine the AR application designed for a museum experience. So how natural feature tracking by detection works in museum experience. So let's discuss. First we have to capture the image. The user points their device at an ancient artifact in the museum. And the second step, feature detection. So the application detects the unique patterns, textures and edges on the artifact surface. And the third step, feature matching. The detected features are matched against a database of known artifacts and identify the specific item. And the fourth step, pose estimation. The app calculates the artifact's position and orientation, which is relative to the cameras. And the next step is tracking. So as the user moves around the artifact, the application continuously tracks its features and ensuring the digital overlay, so which is remains correctly positioned. And the last stage is rendering. So the application overlays a 3D reconstruction and the how the artifact might have looked in its original form, along with information panels explaining its history. So these are the examples how the natural tracking, feature tracking by detection works in museum. So these are the assessment and these are the reference. Thank you.